بسم الله الرحمن الرحيم والصلاة والسلام على أشرف المسلمين سيدنا محمد. أحمد ماجد. Present.
How does the hybrid use of LFSR and NFSR in Grain 128A balance period length and security? Grain 128A is a lightweight stream cipher designed for constrained devices such as IoT systems, RFID tags, wireless sensors, and embedded applications. Its security and efficiency come from combining two shift registers. LFSR, linear feedback shift register. NFSR, nonlinear feedback shift register. This hybrid design achieves both a long period and strong cryptographic security. One role of the LFSR, linear feedback shift register. What is an LFSR? An LFSR generates bits using a linear feedback function based on previous register states. Example: new bit equals S0, S7, S38, S70. Where denotes XOR. Advantages of LFSR. White heavy checkmark simple hardware implementation. White heavy checkmark very fast operation. White heavy checkmark low power consumption. White heavy checkmark can achieve extremely long periods. Contribution to Grain 128A. The LFSR in Grain 128A has 128 bits and is designed using a primitive feedback polynomial. This allows it to generate sequences with a period close to 2 to the 128 minus 1. Before repeating. Limitation. Because the feedback is linear, future states can potentially be predicted. Linear algebra attacks may recover the state. Therefore, an LFSR alone is not secure enough for modern cryptography. Role of the NFSR, nonlinear feedback shift register. What is an NFSR? An NFSR generates new bits using nonlinear functions involving XOR and multiplication-like combinations of bits. Example: new bit equals B0, B26, B56, B91. Advantages. White heavy checkmark introduces nonlinearity. White heavy checkmark prevents simple mathematical modeling. White heavy checkmark resists linear cryptanalysis. White heavy checkmark makes state recovery significantly harder. Contribution to Grain 128A. The NFSR stores 128-bit secret key state and generates highly unpredictable outputs. Limitation. Used alone, an NFSR may not provide easily analyzable long periods. Efficient implementation compared to an LFSR. Why combine LFSR and NFSR? The designers of Grain 128A wanted. Requirement. Best component. Long period. LFSR. Unpredictability. NFSR. Efficiency. LFSR. Resistance to cryptanalysis. NFSR. The solution was to combine both. Grain 128A architecture. Plus LFSR. 128 bits. Plus V. Plus NFSR. 128 bits. Plus V. Nonlinear output. Function. V. Key stream. The output depends on LFSR state. NFSR state. Nonlinear combining function. How the hybrid design improves security against linear attacks. If only an LFSR were used. Output equals linear function. An attacker could use Burley-Camp-Massey algorithm. Linear complexity attacks. To reconstruct the internal state. The NFSR introduces nonlinear terms that break these attacks. Against correlation attacks. Correlation attacks exploit relationships between internal states and outputs. The nonlinear feedback and output functions in Grain 128A make these relationships extremely difficult to exploit. Against algebraic attacks, attackers often try to represent the cipher as a system of equations. The NFSR increases algebraic degree, equation complexity, making such attacks computationally infeasible. How the hybrid design maintains a long period. The LFSR contributes a near maximal cycle length, 2 to the 128-1. The NFSR is continuously influenced by the LFSR. As a result, state repetition becomes extremely unlikely. The key stream period remains extremely large. Practical repetition is impossible. Practical example. Imagine LFSR acts like a very large wheel, provides a long repeating cycle. NFSR acts like a complex scrambling machine, makes the wheel's motion unpredictable. Together, long cycle plus strong randomness equals secure key stream generation. Security, performance balance. Property. LFSR contribution. NFSR contribution. Period length. Excellent. Moderate. Hardware efficiency. Excellent. Good. Randomness. Moderate. Excellent. Nonlinearity. Poor. Excellent. Resistance to cryptanalysis. Poor. Excellent. Power consumption. Very low. Low. Summary. Grain 128A achieves its balance by combining a 128-bit LFSR, which provides a very long period, efficiency, and low hardware cost. A 128-bit NFSR, which introduces strong nonlinearity and resistance to cryptanalytic attacks. The LFSR ensures the key stream does not repeat for an extremely long time, while the NFSR prevents attackers from predicting or reconstructing the internal state. This hybrid architecture gives Grain 128A both high performance and strong security, making it well suited for lightweight cryptographic applications such as IoT and embedded systems.
Thank you for taking the time to reach this. Your attention is appreciated.